Hi, my name is Kate Penner and I'm the head TF for Math 23. This video is an introductory video that goes over the syllabus in general, which we realize is very long and has lots of information in it. We really encourage you to read through it because every single paragraph is in response to a question that we've heard or a particular note that we'd like to clarify administratively. But this video is a short way to introduce you to how the course works and what you need to know about what your responsibilities are taking this class. You can take a look at the course staff. The senior lecturer will be Paul Bamberg. You can refer to him as Paul, and I am the head teaching assistant or head TF, Kate Penner. You can just call me Kate. Over this entire page, you can find all of the contact information for our course staff, and there are a lot of members. Please don't feel limited if you're an extension student or a college student to just the people listed under the course assistants or just the people listed under the extension and distance team. You may find yourself assigned to a section taught by one member or the other, and all of these people have experience either teaching mathematics or specifically experience teaching and taking Math 23. So we welcome you if you ever have a question or you're looking to attend office hours, to attend the office hours of any of the course assistants and teaching staff that you find here. We go through the prerequisites in detail. I'm not going to read them over to you, but basically all you need is a solid knowledge of univariate calculus. That means that if you are a US student or went through the AP curriculum, you need a 5 on the BC calculus exam. And if you're a European student, it's okay if you have never seen series or didn't go through the advanced placement curriculum, but you've gone through maybe higher level math methods, you've done differentiation and integration. We will be reteaching series through a much more rigorous approach in this class. Most importantly, above all, in addition to that technical background, you need to be enthusiastic about math and interested in the abstraction, proving things, understanding why theorems work or where they come from, and experience with proofs is not necessary. We all sort of had some experience in geometry in high school. That's constructing a mathematical argument. That's not really the same level of proving things that we'll be doing in this course, but that interest in the detail as to why things work the way they do and why can we use these particular methods to solve problems, you should have some interest in where that comes from. Obviously, having that interest doesn't necessarily mean that you're going to be a math concentrator. We've certainly had pure math concentrators come through Math 23, but here we've listed a whole bunch of possible concentrations, and it really covers the gamut. Math, applied math, physics, chemistry, computer science, economics, life sciences, humanities. One of our longtime course assistants was a history concentrator. I myself was a government concentrator. So it doesn't mean that you are necessarily a pure mathematician, but if you are interested in going into pure math and becoming a pure mathematician, by all means, Math 23 is a great place to start. First things first, we have lecture twice a week, Tuesday, Thursday from 2:30 to 4. This is going to be usually in Hall A, but for the first week, because of shopping period, we'll be in Hall C in the Science Center. You have the choice of attending either in person or watching the lecture videos. So that's one type of course meeting. This will provide the major narrative framework for the material that we will be covering. The other two types of course meetings that you'll have each week is that you'll be assigned to 2 sections. One of them is required, one of them is optional. The first one that's required will take place either Thursday or Friday, depending on which section you are put into, and this is what we call early sections. They work on active group problem solving. They are mandatory. They encourage you to get to know some of your classmates and become more familiar with the material that you've seen in class that week. They bridge the material in class with what you'll start working on in the problem sets. And they're a great opportunity to help people get their feet wet with problems in the presence of a course assistant or member of the teaching staff. The later section happens at some point on Monday. You'll be assigned to one. That attendance is optional to the later section, but this is a typical recitation style section. What this does is it allows you to review particularly tricky or difficult proofs or concepts from the week, maybe a problem that you had difficulty understanding, or you have a question on your homework, or you want to review a proof, that's where you go to get those questions answered. Monday section. And while attendance is optional, every single person will be assigned to a Monday section because this assignment will give you the person that you should be submitting and collecting your homework to and from, respectively. Sections will not begin this week. They will begin next Thursday. So that's going to be September 10th and 11th are the first section meetings. Those will be the early sections. And then the following September 14th will be the first meetings of the late sections. So no sections for another week. We will be sectioning in class on Tuesday, as well as online for the distance students that are watching us right now. I should mention before I dive into the other pieces that you'll be responsible for in this class that there are going to be weekly office hours held by every single member of the course staff, and they are really encouraged. And in fact, most of the candidates that we have for course assistants who were successful in Math 23 made regular appearances at office hours, talking about math, getting to know other people, discussing some of the problems and the proofs. That's what really improves your skill the most quickly as a mathematician. So we will have office hours schedules posted to the course website. They aren't mandatory, but they're strongly encouraged, so do keep an eye out for those. All right, what will you be graded on? There are going to be 2 quizzes and 1 final exam. Here are their dates. They will be held in Northwest B 103. The 2 quizzes will be. We'll be given a location for our final exam at a later time by the registrar's office. Please keep these time slots open. Don't schedule a section. Don't schedule a lab at those dates. If another class has an exam during this time, please let us know and we can make alternative arrangements for you. A secondary note on the timing of the exams is please note that our add drop deadline actually comes before the first quiz. So keep an eye on how you're doing in the class. It's never a good idea to drop or add a course 5 weeks into the semester regardless of what course you're taking. We want to make sure that your experience is as stress-free as possible, so if you're really feeling like you're falling behind, keep an eye on that. Come, talk to course staff, talk to myself, talk to Paul. We're here to help you, and just be aware that you should not be waiting until you get that grade back on the first quiz because the first quiz is after the add drop deadline. You cannot leave the class after that point. Here are our textbooks that you'll be using. One is available for purchase. I would suggest getting a hard copy of this, and depending on your preference, you can get either a hard copy or read the Ross text online. Most people prefer the online version. It's completely free through Hollis, and I would certainly get the free download for the Lavier text as well. So there's lecture, there's sections, there are exams and quizzes. What else do you need to know about Math 23? Well, the big thing about Math 23 is that it's this bridge from computation-based mathematics, what you learn in calculus class, to higher level math and being able to prove things. And what we've discovered is that proving things can be a lot of fun, and we've created a nice environment for students to be able to do this. We want people to learn how to prove things, feel confident in the proofs that they know, and the different ways that they work. And here's how you get points for proving things. Every week there will be 2 proofs that are highlighted in the lecture notes, about 2 proofs, I should say, that are highlighted in the lecture notes, that you will be responsible for learning by heart and proving on your own. This does not mean that you memorize every single line as it's done in lecture. This means that you understand how it works, and if someone asks you to prove it to them, maybe your notation would be different, maybe you'd word a particular line slightly differently, but that you understand enough about how this proof flows that you're able to do it on your own. Note that this is the most effective way we have of instructing people on how to learn proofs. You're going to be given a bunch of examples, and so you'll watch and see the different methods that are used in these proofs for how to prove these particular theorems, and you'll get a larger and larger toolbox of different techniques that you can use. So when a theoretical question comes up on your problem set and that says prove this, you have this arsenal of different techniques that you've learned from the proofs that we've covered in class that you can maybe apply to this particular situation that you're being asked about. So each week we have about 2 proofs that are presented to the class, and you're charged with learning them by heart. And once you think you've done so, what we want you to do is we want you to go to an authorized listener. And when a proof is reached in class, the only authorized listeners, the only people that are allowed to listen to you do the proof by heart are the teaching staff. So myself, Paul, any course assistant in the course, they are the authorized listeners. I'm going to write them down in blue. So say you feel pretty comfortable with the first proof that you're going to learn. It's about field axioms, which you'll learn about in just a second, I guess, if you're watching the lecture video after this. But say you're a student and you feel confident enough and you show up at my office hours and you say, okay, I know it by heart, I'm going to prove it, and you either do it on a chalkboard or you do it on a piece of paper, and I say, good job, you've learned it. This is my little student here who's come to my office hours to prove something. I say, good job, you've learned it. What you're going to do is you're going to log onto our proof logging software and say, I presented this proof to Kate. When I log into my proof logging software, it says, oh, you have a pending proof to confirm, and it says, this student presented the proof to you, please confirm. And when I confirm that, lo and behold, this student goes from being an average student about this proof to an authorized listener for this proof. So they are going to turn blue too. Of course, my drawing is completely terrible now, but that's okay. And they've been added to the list of authorized listeners for that proof, and other students can present to this student. Now, there are a few rules. You can only present a proof once. So that very first proof, you can only present once. Once you become an authorized listener, you can no longer present that proof. You can only listen to it. And the other thing is that we do want to incentivize people to get these proofs done sort of on time as the semester progresses, because this process resets for each proof independently. So when we reach the second proof for the class, again, the only authorized listeners are the teaching staff, and a student, once prepared, will make an arrangement, walk up to a particular course assistant and say, I'd like to present a proof to you. And then they'll say, okay, go ahead, present. They'll do it successfully. They'll become an authorized listener, and then other students will be able to present to them. And so it's a great way for you to get to know other people in the class, to boost your confidence with some of this pretty tricky mathematics. And we think it's a wonderful way to bond the class together. Now, a few questions. One is, what happens if I don't prove my proofs correctly the first time? Well, that's okay. It's not supposed to be like the Inquisition. You know, as the authorized listener, you are able to give a few small hints if someone gets stuck, but if they are really lost and they just don't have it, they thought they did, but they're not ready, that's okay. They'll just go off. They won't get the credit for presenting at that time. Go off, work on it a little bit more, come back and present it again. You can't have any notes while you present. The only thing you can have is the proof statement and any information you would have if it showed up on the exam, which we will tell you. There's a list of all the proofs that you'll be given. There's no partial credit. You either successfully prove it or you don't, and it's not the end of the world if you don't. You just work on it a little bit harder, come back, try again. These proofs are candidates for showing up on the quizzes. So the proofs that are covered in the first 5 weeks of the class might show up on the first quiz. And so if you successfully present a proof before the first quiz, you'll get 0.95 points for it. If you let it slide out and it's after the first quiz, we'll give you 0.8 points if you successfully present it to someone. So what we want to do is use this proof logger as a way to prepare yourself for the quiz, because one of these proofs may show up. Well, a couple of the proofs will definitely show up. You're not really sure which one, but a given proof may show up on the quiz. So this is a way for you to learn math, prepare for the quiz, stay on top of the material, and earn a few points towards your grade. We will be unveiling the new Proof Logger software, which is a social networking app, you can call it. It's not really an app. It doesn't have a mobile interface quite yet. But we will show everyone how to activate an account and sign up and get started, and exactly how to log your proofs once shopping period settles down. All right, homework. Every week there's going to be a problem set. Don't worry, there's a while until the first problem set. It will be due on September 16th. That is the first due date for the problem set. So that is the very first Wednesday that a problem set is due. We generally do not give extensions except in cases of medical emergencies and personal emergencies. Please contact me or your course assistant if you find yourself in need of an extension. But if your homework is late, you have until the end of reading period to turn it in for 50% if it looks somewhat correct. So you should submit those to mailboxes on the second floor by room 209 that will have your late section CA's name on them. For those of you who are distance students, you'll be submitting your homework electronically. Students also have the opportunity to do that who are local students, but you do need to okay this with your CA first. We do assume that students will be working together on the problem sets. It's very, very important to acknowledge the students that you are collaborating with on your assignment, specifically writing it out. If you happen to discover a solution to a particular problem, even if you just read over that solution to make sure your solution is correct, you should acknowledge that you've done so. This is how we work around academic integrity policy. So please be aware of that and please make sure that you are doing that. So if you are working in a group, acknowledge all the students, and if you are using any outside sources at all other than our textbook or lecture or anything like that, those things don't need to be cited, but if you find some other textbook or you find a solution to a problem online, you must say that you have looked at it, even if you didn't use it as inspiration. As is course policy, it's really important that everyone's aware of the honor code. So whether you're a freshman, an upperclassman, or an extension student, please take a moment and review this. It is going to come up again and again over the semester. Math 23 is a really challenging course. It's pretty much the first time a lot of students really begin to struggle conceptually with mathematics, and that's completely normal. It's sort of the growing pains of the class. And so it's important that you understand where to get help. First, there will be course assistant office hours every single week. Lots and lots of hours. You can go to as many or as few as you like. It's really important. Some of the best students in the class have come through office hours and been familiar faces in that setting. But if you're more of a one-on-one person, you really feel like you need some remedial work, there is the BSC, the Bureau of Study Council, where there are several tutors available. So we've had several really good students in Math 23 in the past who are just too busy to be course assistants, but they are willing to be Bureau of Study Council tutors. And so if you find yourself in need of some more private assistance, please check out the Bureau of Study Council and sign up for a tutor if you're interested. A few notes on software in the course. You will be learning LaTeX. It is an excellent skill to have. It's basically how we've created all of the course handouts for this course, so it's a really nice typesetting language that allows you to write in mathematics really easily. This equation editor that's in Canvas is based off of LaTeX, and basically what we're going to do, LaTeX doesn't take a ton of direction. We're going to upload all of our tech files which show all of the source code for generating these particular handouts to the course website. And we're also going to have a how-to LaTeX, we'll say, seminar in the first few weeks of the semester once shopping period has ended. So keep your eyes peeled for that. But here are some download instructions, and part of your grade is to upload 4 proofs of your choice to the course website. And not only are there 4 proofs of your choice, but you can use any medium of your choice. So a lot of people like to write up the proofs in LaTeX. But some people like to do a YouTube video similar to this one. Some people like to do an actual video where you can see a person instead of a screencast. It's totally up to you. I will say that if you're using LaTeX to write up your homework, which some people do like to do, it's important to note that a few things are not allowed. One is that you can't send the tex file of your homework. There's a .tex, which is when you run that file, it generates a PDF that is your handout. Do not send tex files. Please only send the PDFs that they generate when you run the code. And also, if you are an in-person student, that means that you're not a distance student, but you prefer to submit your work electronically, please contact your course assistant and see what their preference is. Are they okay with you emailing it in? Are they okay with you uploading it to the course website on the Canvas Dropbox? Or would they prefer that you print it out and submit it hard copy? Just make sure that your course assistant's sort of in the loop as far as what format you want to submit your homework in if it's not a hard copy. If you're interested in learning R, as Paul has mentioned in lecture, this is only required for extension students who are registered for grad credit, but it's open to everyone. And here's some basic background about R. There are some ways to earn R bonus points, a small amount of extra credit that you can find out about in this section of the syllabus. All right, so what are all the components that go into your grade? Well, you have your homework, which is due every Wednesday, starting on the 16th of September. You have presenting and listening to proofs. There are 26 proofs, so it's 26 points. We're going to put a cap of 30 points on that component of the grade. Remember that you can listen to as many proofs as you like while you present each one only one time. Uploading proofs to the course website, you want to do that 4 times over the semester. Again, medium is your choice. YouTube video, LaTeX document, whatever you like. Participation in early section, that's attendance, preparation, contributions to problem solving, posting solutions, that's 10 points. We also have 2 quizzes, which are 40 points a pop, that's in October and in November, and then there's a final exam, and some R extra credit. So those are all the things that go into sort of the stew pot of your grade, and we really want to stress that when we look at grade cutoffs, these cutoffs have already been decided. There is no conversation that will involve discussion of the mean, discussion of the standard deviation, so please do not even bother to ask. It doesn't matter how your classmates have done compared to you. You can take a look at this and look at the grade cutoffs for the semester. There is no curve in the course. If everyone gets a 94%, the entire class gets an A at the end. Well, what will we be learning? Let's take a look. Down here we have our week-by-week schedule. We start out with linear algebra. These are our first 4 weeks. That's going to get up through eigenvectors and eigenvalues. That quiz 1 will be on weeks 1 through 4. Then we'll have 4 weeks of univariate analysis. That starts with numbers, systems, and sequences. That's week 5. 6, 7, and 8, derivatives, inverse functions, Taylor series. That's what quiz 2 will be on. Then we're going to do sort of a mix of things, pulling from linear algebra, pulling from analysis. And so that's the third part of the semester that the final exam will be stressing the most. This is enough math to cover a bunch of different classes and a bunch of different types of preparation that you can read about down here. But now let's take a look at what a typical week looks like in Math 23. So how does this all layer on top of each other? All right, here are 2 consecutive weeks in Math 23. Let's look at all the things that are happening as the semester goes on. On Tuesdays and Thursdays, we have class. Now there's also early section that's happening somewhere between Thursday and Friday. Remember, you'll be sectioned into those at the beginning of next week. So say I'm assigned to a Friday section. So I go into my Friday section, I work a little bit with the problems, I get to know some other people in my class, I work with the CA, I ask some questions, and I get out and I am set and ready to roll to work on homework over the weekend. And I'm not saying all weekend long, I'm saying a few hours on Saturday, a few hours on Sunday, a few hours on Monday. And on Monday, I'm assigned to a late section. Here I'll ask more questions about the homework, I'll get more answers, and then I'll work a little bit more on Tuesday, finish up my homework, and then on Wednesday I'll submit the homework. Yes, we'll be moving on into new material on Tuesday's class, and the Tuesday and Thursday here will have their own homework that'll get due the following Wednesday, and it'll continue like that. Note that there will also be office hours throughout the weekend. Usually we have office hours scheduled Saturday, Sunday, Monday, and Tuesday to help you guys as you're sort of making your schedules work for you. But this is a general idea of how the semester will start. Note that this first particular column refers to next week. We'll have class Tuesday, class Thursday. Friday is when early sections will begin. Next weekend is going to be the first time that you're really doing a Math 23 problem set in earnest. And then it will be due, this would be Wednesday, September 16th, and so that continues. If you have any questions at all, please don't hesitate to ask, but we've put so much information into the syllabus because there are so many questions. There are a lot of different moving parts of this course, but we think that once things get off and rolling, you'll find it nice and fun and a really good time. A lot of people think it has characterized their entire freshman year experience. So what do you need to know coming out of shopping week? Coming out of shopping week, I'd love to stress that the only prerequisite for this class is a 5 on the BC Calculus exam. You do not need to have taken multivariable calculus before. You do not need to have taken linear algebra before. In fact, you don't even need to have taken AP BC Calculus. Maybe you come from a European school where you don't have the AP program. That's okay. We want you to be able to feel secure and solid on differentiation and integration. Even if you haven't seen series before, that's okay. You do not need experience writing proofs in advance of this course. Maybe you've done a mathematical argument or two in geometry class, but you don't need experience. Lecture is twice a week, Tuesdays and Thursdays at 2:30. We're going to start at 2:35. The first few pages of the lecture notes were provided on a handout in class. We encourage you guys to print out the rest and bring them with you if you prefer to have a hard copy. We will not be providing them, though. Each student's going to be involved in 2 sections. One will be mandatory, one will be optional. The mandatory one is the early style section that will take place on Thursdays or Fridays, depending on the time you get sectioned into. And the late style section is on Mondays. Sectioning is going to happen in class when we get back from Labor Day. So that's Tuesday, September 8th. And it will be happening via email for our distance students. Sections begin Thursday, September 10th for early sections, and Monday, September 14th for late sections, and that first problem set will be due the following Wednesday, September 16th. Introductions to the proof logger and LaTeX will be organized later in the semester once our enrollment has finally settled down. If you have burning questions about exactly how to handle switching courses and things of that nature, there's sort of a miscellany option attached to the end of the syllabus, and there are a couple comments throughout. But the basic idea is this is a difficult course. It's going to feel different from every other math class you've ever taken, and that's okay. This is a transitional course that takes you from computational-based mathematics to abstraction, and it's a ton of fun, and I'm excited for all of you that are planning on joining us. See you soon.